So for our Bench Exam 2 project, we chose to create a pulse meter. The pulse meter works by using a photo sensing diode and a photo emitting diode. When the photo sensing diode is able to capture light emitted by the LED in a finger cuff, which would be in the absence of blood flow through the finger, the photo sensing diode lowers its resistance and allows a larger voltage to travel through the circuit into our first stage, which is a signal amplifying stage. The signal amplifying stage is coupled with a diode that serves as a source of visualizing what the gain is in the circuit at the given time. This is coupled by a potentiometer that allows for variance of the gain of the circuit. In essence, when the light is on, we have too large of a gain in our circuit, and when it's off, we have too little of a gain. So this was used to set about the middle point threshold by picking when the LED was dim but on. This output passes through into a second op amplifier stage. This op amplifier actually acts as a comparator circuit. When the voltage of reaching the comparator is above threshold, the voltage output jumps to V high and the emitting diode at the end is able to be lit. This indicates the lack of a pulse because the photosensor is able to produce a high enough voltage to reach this V high. Likewise, when the LED is off, the voltage is too low and indicates that of a pulse. This is then sent to an Arduino microcontroller for further processing.
For our Arduino code, we started out by having the value of V read the output from the pin A0 on the Arduino. Starting out, we set an if loop with the V compared to a threshold value of 250 bits. 250 was chosen as an intermediate value during the cycle of a pulse. If V was greater than 250, then we added 1 to our check 2 value, which was originally set to 0. Within this, we had another if loop where if check 1 was equal to check 2, then 1 was added to our heart rate value, and check 1 is set at a value of 1. After this, the new heart rate would be printed. This makes sure that if V stays above threshold, there's still only a value of 1 added to the heart rate. If V is less than our threshold value of 250, then the check 1 and check 2 values are both reset. That way, if threshold goes from below 250 back up to 250, then a new value is added to the heart rate. We added a delay of 50 to the end of our program to avoid any misleading increases in heart rate due to fluctuations around the threshold.
Alright, so problems we encountered with our circuit. The first one was with our finger cuff. We have an IR light and our photodiode in the cuff. Unfortunately, the photodiode burnt out during testing, so we could no longer use biological signals. So instead, we got a photodiode that senses normal visible light and an LED, and that's what we've been using for our demonstrations and testing. The second problem that we encountered was with our code. Since the data coming in has minor fluctuations and our code uses a threshold to determine heart rate, those minor fluctuations can sometimes cause the code to count an additional heart rate when a full heart cycle hasn't passed. So in future work, the data could be further smoothed so that this code doesn't accidentally miscount heart rates.
So for the testing of our device, we are going to do a quick run through of starting with our Arduino code and showing the initiation of that code. Then Maddie will begin by creating a few different pulses underneath the lovely table there. And as we observe the pulses, we will show a final output of the code. So starting, we'll begin running the serial plotter, at which point Maddie is under the table here, so we can see we're starting with a blue light indicating that there is no pulse being sensed. And then as Maddie begins to bring the photo sensor closer to the light source, we can see the yellow light begin to turn on and off as she does so. Every time the light turns on, we record a value, and that is proportionally plotted in the Arduino serial plotter.
We have